This lesson is on displacement and average velocity. Okay, so it's something that we're going to talk a lot more about, but it's on motion. Okay, so we're going to have to calculate the average velocity given a displacement function, and also understand that in motion x means displacement and t means time. Really, really important concepts that we're going to get to know very, very soon and be really, really good at. Okay, but like the best thing is, let's just do a example. Now, this is actually advanced motion, all right? And what that means is that we're only doing motion like in a not even linear, up or down, so up or down, or side to side. So we're not looking at something that's a 3D ball being thrown or anything. In this case, what we have is there's a ball that's thrown straight up in the air. Okay, so we're tracking the ball as it goes up in the air and it comes straight back down. So as it goes up and then it comes straight back down. Okay, we haven't thrown it across a room or across a field or anything. Just as straight as you can up and down. Okay, and its displacement is described by this formula. Now notice here that this is displacement. Now, if I was just normal calculus and it wasn't motion, this same function could be written like this. Okay, but we're not doing just normal calculus, we're doing something in terms of motion, so it's displacement in terms of time. Okay, so the x means something very different to what we're used to. And let me draw what it means. What it does mean is that displacement is on the y-axis, that we know it, and time is over here. Okay. Now, if we can factorize this, so I'm going to factor this out. X equals, let's factor out minus t out of it. Then we get t minus 10. And I know this is a negative parabola because of the coefficient of t. So somehow we've got a graph. Let me draw it properly. That is upside down. That is so bad. I can't get my hand in a good position. There we go. So that's 10 and that's 0, because if we factored out that situation, we'll get that. Actually, somebody's already screaming at me. That is actually 20, so that will be 20 there. Okay. Just so you know, because it's going to be really important, that the x here does not mean the x that we normally use at. It actually takes the y dimension. Okay, let's do the questions. All right, so we've got this function of displacement. How much has the ball been displaced after? Now, displacement is very, very closely aligned with distance, but it's actually not distance. It's actually, we've got an origin. Displacement is how far are we from the origin, okay? So, yeah, you're telling me that's the same thing as distance? No, it isn't, because we could throw a ball up in the air and it goes up and then it comes back down, and I'll ask you how much displacement is it from the origin, and it's just this little blue bit, okay? So displacement is just how far it is from a relative point. Often in maths we use origin. Okay, let's do it. So how much has the ball been displaced after 5 seconds? Well, t is time. So in this case, we'll go at t equals 5, x equals, so I'm just using this formula, minus 5 squared plus 25, because I'm replacing it in terms of t. So I end up getting minus 25 plus 100. So therefore, displacement is 75 meters when t equals 5. Now, in motion, unless told otherwise, t is seconds and displacement is meters. All right, you can change the units, but it's not often that happens. This is the case most of the time. Okay, so that's the first one. The second one, I don't have enough space, so I'm just going to have to rub it off. So if you need to pause your video, please do that now. Okay, so we're looking at t equals 10. So we're substituting into the same formula because we're finding displacement. So we get x equals minus 10 squared plus 20 times 10. And we get displacement is equal to minus 100 plus 200. Therefore, x equals 100. Therefore, displacement at t equals 10 is 100 meters. All right. So the ball is actually pretty far up now. So we're throwing it from the origin, throwing my hands, and it's like after 5 seconds it was 75 meters high. After 10 seconds it's 100 meters high. So it's going pretty fast and far at the moment. That's one hell of a throw, let me say that. Okay, let's see what's happening after 15 seconds. So I'm going to do the same thing as I did before, so please pause or rewind it. So after 15 seconds, let's see what happens. X equals minus 15 squared plus 20 times 15. And we've got 15 squared, we know is minus 225. Plus 20 times 15, 10 times 15 is 150, 20 times 15 is 300. So we end up getting that displacement is 75. Therefore, after 15 seconds, it is 75 meters from origin. Okay, I know that I wrote it very differently to what I did previously, but it's for a very good reason. I just want you to see that they're of equal value. Now what's happening? After 10 seconds, how far was it? 100 meters. After 15 seconds, it's now 75 meters away. So what does that tell us? That the ball reached as far as it could go, and now it's headed way back down. Okay? So it's heading on its way down. It's already gone at least 25 meters down because we know that it went at least 100 meters high. So it's on its way down. So just so you understand what we're talking about. All right, let's do the last one. We're going to try to do it quickly. So we've got t equals 20, and we've got x equals minus 20 squared minus 20t. And 20 squared or that is going to be the same thing, so I don't know why there's an x there. X equals 0. So what that tells us is exactly what we saw in this parabola. The ball's gone up to its apex and it's gone back down at t equals 20. Okay? So that's it there. Okay, let's answer B. When in seconds will the ball be 19 meters away from the origin? So we've got a sub x equals 19. Okay, so let's go 19 equals minus t squared plus 20t. Okay, so from that we'll find out. I've actually done this one before. It's on the diagram, and it's going to be, there's going to be 2 places that it's going to be. So I'm going to make this quadratic. I'm going to move everything to that side. Okay, so it's going to be t squared minus 20t, if I don't stuff this up, plus 19. Okay, so I'm going to play magic numbers with 19, and it has to be -1, -19. So t minus 19, t minus 1. Therefore, t will equal 1 or 19. So when will it be 19 meters away? At at 1 second or 19 seconds, all right? And so from this graph that we've got here, you can see after 1 second it will probably be there, and 19 will be the same thing. So 19 meters away after 1 second, the ball's thrown up in the air and it's 19 meters away. Now, after 19 seconds, it reaches the same point, but now the ball's heading on its way down. Hopefully that makes sense, okay? All right, so let's use the same equation for what is the average speed. So speed equals distance over time, okay? So what is the average speed? So what is the distance after 5 seconds? So we already worked this out. The distance after 5 seconds was 75, okay? And the time was 5 seconds, so we're going to go 75 over 5. And we're going to pop this in our calculator. So we just go 75 divided by 5. Some of you have already done it in your head. So it's just going to be 15 meters per second. So speed is going to be 15 meters per second. Now, it will be the average speed because that's how much it's done. What would the average speed be in the first 10 seconds? Well, and after 10 seconds, we found out that it was 100 meters away. So we go speed equals 100. What time was 10? And what happens is that it's going to be 10 meters per second. Okay. So what's happened? Why has the speed changed dramatically over that time? Well, essentially gravity has started taking over, so it slowed the ball up. So the average speed has changed a lot. Okay, so the average speed has changed. Now, I should be using a different formula that I've used right now, but it's quite intuitive to use it this way. Let me explain. The average speed formula will be x2 minus x1 over t2 minus t1. Now, x2 will be the speed at t equals 5 seconds, which is 75. Now, x1 is the time that we let it go from. So we left it go at time equals 0 because we didn't start timing until we threw the ball out. So it's going to be 0. And the same thing goes at the bottom. It's like, what was the time when it got up to 75 meters? Well, it was 5 seconds minus, what was it? 0 seconds. Now, this will become really important, this formula, for these questions down here. It says, what was the average speed during the second second? All right. So so the first second happens between 0 and 1 second. The second second, so let me draw a little table of values because it will help us out. So we go x and t and x. So what happened at 0? Well, it hadn't been left over. At 1 second, we figured out that it was 19 meters away. At 2 seconds, how far away is it? Let's substitute 2 into our formula. So equals minus 4 plus 40. So x will be 36 meters away. Okay. So 36. So it goes, what is the average speed during the second second? Well, the average speed will be what it is at 2 seconds. So it'll be 36 minus 19. So during that second, and then it will be at second 2 minus second 1. So essentially it will be just whatever 36 minus 19 is. So what is that? It's just 17. So it will be 17 meters per second. Okay. Now the last one, it goes, what is the average speed during the last 3 seconds? So the last 3 seconds will be 18, 19, 20. So what will it be during those last 3 seconds? Well, I'll let you figure out, because I feel like this video has been too long, and let me know how you're going. I might get you to email that to me. What you might find is that you might get a negative answer. Now, you don't have negative speed, all right? So speed is always the absolute value of velocity, and we'll be talking more about that in lessons coming up. Anyway, peace out.